So the content of this lecture today anyway. So we'll start with theory. So some idea about all this MVC, MVP, MVVM stuff, and what is this about, and how do you organize your UI application. And we'll look at some elements out of the practice. I think constraint layouts I skipped because I got to remove from in week 2. So, and then lazy initialization as our pattern of the week. So, theory. So, what we want to do is synchronize our UI with our data. So basically, when we have an application, the problem is like you have data on one side and you have a way of displaying it on the other side. And ideally, that is the same. And if it's just displaying something, that will or easily stay the same. But there's two kind of situations that can make this different. One of it is if you have UI controls, then the UI controls, you have a text field, people edit something, then the UI control has to change text, but your underlying data may not have changed. Sometimes that's what you want. You want a temporary thing and people press the OK button and then it changes, but sometimes that's not what you want. Another case could be like the data might be updated externally from the internet or something like that. And then you say, okay, actually, I want to update my UI as soon as the data changes. And that's kind of what this whole problem is about. How do you kind of manage the synchronization of that data? And there are some standard approaches to do that. So, because also what we want to do is do this with generic controls, like generic UI components. Like in Android, it's called a view. But I'll try to call it control today because view is also used for other purposes in Android and in also this thing. So with model view controller, again, there's a little terminological overlap that's not very helpful. Of course, we also put in the UI things like how you arrange your controls and there's another reason why you might want to use these approaches, and that is if you somehow can make most of your application independent from your UI, it becomes much easier to test it. So you can test your UI or test your application very easily without having to do UI testing. You can do UI testing in Android, but again, it's much more brittle, much more fragile than regular unit testing. And it's slower, a lot slower. So what you want to do is kind of separate it out. Also, if you want to have multiple UIs for multiple platforms, it makes sense to separate stuff up. So when we have an application, so basically where does the data live? It lives partially into some database. It might be, and then you might have in your application, you also have the data still as data in memory, because you can't. So sometimes you can work directly on the database. In many cases, if you have something really complex, you also have a working copy in memory that you're working with. If it's a complex structure, you can't just directly work with SQL queries. And in many cases, you also kind of want to kind of isolate the whole SQL part to a particular part of your application that deals with SQL, so the rest doesn't need to worry about that. That's a bit of a challenge how to do that, but is in the end what you want. And of course, UI components also have screen state so that they can display, etc. So if we have a client server like an Android application with a web backend, something that should be familiar to all of you, in that case, we actually also have storage and memory. In that side. So we have a server that stores stuff. The server might have some in-memory structures as well. But then we also have a local cache or a local storage that needs to synchronize the server. The local application has some memory and it has display. So, and they're also not, it's not only about data, it's also about rules and logic. What they call in the field, they call business logic. Of course, if we have a game, that would be game logic. but the normal term is business logic. That's just what it's called. So basically that is, okay, making sure all those class invariants do not get violated. So that's what we can do with the logic. So, and our challenge then, of course, is how do we keep this all consistent? So, how do we keep this consistent? So, first of all, what you want to kind of figure out, where is the master data? And that's something you want to decide yourself. Which database is the boss, so to speak? And normally you might want to use the database, but sometimes it's in program memory, and you just write out when you need to. That depends a little bit on your application. In many cases, you are working with generic controls. In that case, you need to somehow link your application with that generic control. Very different from in the game when you're going to use a custom view. The custom view basically can know more about what is displayed, so you can actually have the custom view directly display your game rather than having to store the game state in the custom view and then the custom view works. That's the advantage of having a custom control. So we don't need that linking up thing. We don't need two states. Because two states is a bit of a challenge. So we have a control that is not generic. We don't need it. And yeah, if we so high scores, we might want to actually use a database and stuff like that, or data storage. So then the solution of data binding is one of the ways you can do this partially. And so basically, data binding is the idea of often automatically having the idea so you have data that actually can tell you about, oh, I've changed, and then you use these kind of controls to link it all up. Big challenge. A big challenge there is cycles. So what is this problem with cycles? The problem is that you have applications that, so basically you have your control, your edit text, and you've got your data structure that contains the text. So the user edits the text, then the edit text says, okay, it's been edited. I'm going to edit the text in my data structure. The data structure says, oh, I've got changed. Let's inform the edit text so that he can display that. The edit text, oh, you're changing the text. Let's inform the data structure. So the very basic thing you need to do is check. If it didn't change, don't send a change event. Or have an alternative way where basically avoid, or you might have a flag. So I'm already handling a change, so I will not accept the same change again. You can do it, but it's a bit complex. And preferably, you don't want to do that by hand or yourself. It gets really tedious really quickly. So that is what you want to do in a way. So the basic part of the challenge is you want to use forms, or in an Android form that would be layouts or activities. But a general term of it is often called a form. The form, so you have put controls on that to display stuff and to allow for user interactions. And the form observed interactions and forwards it to the correct controls. It might also be able to respond to control events. Like, okay, the control says, oh, I changed my size, lay out all the rest. And simple data edits you can do through data binding, but if you have something more complex, if you want to actually say, okay, I want to make sure that this edit text only accepts phone numbers, so numbers, maybe a pound sign or a hash sign, and so maybe a dash or a space, but nothing else. Of course, edit text and endnote can support that, but suppose you wanted to do that by hand. You need to put in logic somewhere. So why do we want to separate these concerns? So partially it is to be able to actually make our components reusable. And that's both our logic components and our UI components. So our logic components, we want to be able to do testing, we want to be able to do multiple platforms, etc. For our UI components, a good reusable control like a button, why do you need to create, you don't want to have to create a new button for every action. You want to have the button perform. Edit text is the same thing. Probably the most complex control in Android is the edit text control. You don't want to know the complexity that goes in there. I mean, if you want to, you can have a look. The source code is there. But we want to manage complexity. So, as you know, programming is very much about managing this complexity. So we have code that is, so doing all these things in some ways increases the complexity, but the idea is that you kind of compartmentalize your complexity. One module, one part does one thing, another part does another thing, and you can kind of know what the responsibility of each module is, and you can think about them. Okay, now I'm looking at UI, I just want to care about how UI works. Or now I'm looking at the logic, I'm just looking at how the logic works. So yes, testability, as I said, and one of the things you can also do is you have two different teams that look at the different parts. And because we have decoupling and testing, that should work. Well, there still needs to be communication between the teams, obviously, but you can work in that way.